Hello folks, I'm excited to review a great new product from Carol's Mac Mods called the Fat Mac Switcher. Something magical happened to me way back in 1984 when I turned 13. My father was given the opportunity to either take a cash bonus that year or the groundbreaking new computer from Apple. He chose the latter, and my computing life was forever changed. That was the very first Macintosh. Like this one, sporting an 8 MHz 68000 processor, a 400 kilobyte 3.5-inch internal floppy disk drive, and 128 kilobytes of RAM. And yes, that's a picture of me that was taken a few months before the Mac's official release in about mid-1983. The first Macintosh was an insanely great home computer at the time, bringing the mouse and the point-and-click graphical user interface to the masses. Some pundits in the early 1980s, and even to this very day, proclaim the first Mac was a failure. Now, I disagree with that, primarily because we still have the Mac today. Oh, sure, the Mac didn't sell as well as, say, the Apple IIe did back in those days, or even like a Commodore 64, but the comparatively higher-priced Mac still largely met Apple's sales expectations by selling 72,000 units in the first 100 days, 250,000 units by the end of 1984, and another 250,000 units only 9 months later. Compare that to its predecessor, the Apple Lisa, which sold a total of 10,000 units in a 2-year span of time, resulting in a $50 million loss for Apple. Compared to that, Apple sales weren't too bad, all in spite of critics moaning about it being slow, overpriced, getting hot, and being RAM deficient. People who actually bought and used one instantly fell in love with it, and I was certainly no exception. So, you want to buy a Mac 128 today? Bad news. eBay pricing makes it hard to afford one. Why so expensive? Well, because so many people consider it the first Mac. But actually, the 128K Mac has a twin called the Mac 512K, or Fat Mac. This Apple reseller brochure makes it clear that the only difference is the amount of memory inside. That's it. Now, because those two machines really are twins, released only 9 months apart, it's kind of splitting hairs to differentiate which is the first. But the fact is, many people do split those hairs, but that's actually good for you. You see, the high demand for the 128K model means most people overlook the 512K Mac, which sells for lower prices as a result. That's great for the frugal vintage Mac buyers like you because you get the benefit of more RAM too. So why buy the Fat Mac Switcher? Because it lets you have both 1984 Macs in the same case. You get to see what it's like to rip out your hair in frustration due to the limited 128K of RAM, and it can possibly let you run some very old software that will only run on the 128K model. Then when you grow weary of that, you can just flip the switch and go back to the more usable 512K. Now, looking at K's website, we see that the Fat Mac Switcher is compatible with 128K and 512K motherboards. Installation is harder on the 128 because you have to desolder all 16 RAM chips, then install sockets, and buy new RAM chips to make it a 512K board. But it's very doable. I've put links to the required RAM chips and sockets for you in the text description below. Now, I only have a 512K Mac, but actually that's a good thing because I don't need to touch the RAM chips at all, and the Fat Mac Switcher will let me switch between the stock 512K and 128K. Sound good? Okay, let's get started. If you have a 128K motherboard, this is the kit that you need to buy. Specifically, if you have the motherboard that is the 1983 motherboard. The newer board is a little bit different. And you will get the circuit board and the header, and note that yours will be a little different than mine because mine has the switch already soldered on because I'm located here in Japan and there's not any shipping issues for me. But Kay will ship to you, I believe it's in a flat bubble pack, and so he was worried about the switch piercing the pack or otherwise being damaged, and so he is not going to solder this little toggle switch on yours, so you'll need to solder it on. And it's not hard to do, very easy. And it doesn't matter if you flip it 180 degrees or not. it's not keyed. So long as you mount it this way, the IC side of the board, and don't mount it, on the back, then you'll be fine. And if you have the 512K motherboard like me, or one of the newer 128K boards, which is switchable at the factory between 512 and 128, then you will need this adapter for 512K. So you'll get all of these parts in that case, and these header pins, which you'll need to cut. We'll go the 2 rows here. And then, if you want to be able to flip this switch without removing the motherboard, you will need to buy an optional ribbon cable, which K does not sell. And then you'll need a 90-degree header. The pins are shaped like an L. And if I move it over here, you can see it. So what this does is it's an extension cable. And you'll use these headers to connect these 2 boards through this cable as shown on Kay's website. Kay very nicely shipped me these 2 parts just so that I could show them to you. But normally you would not install it with these 2 parts. You would just install it with this kit if you have a 512K. And in the case of 512K, you would stack the boards on top of each other, as I'll show you in a few moments here. But the extension cable will move this little switchboard further down into the back of the motherboard. The only issue that I'm kind of concerned about is you'd have to use double-sided tape, and that's not going to last forever, and I don't want to short anything out. So maybe if you heat shrink the board or do some other tricks to protect it, that might work. But basically these 2 parts are only needed if you don't mind distancing these 2 boards, pushing this towards the back so you can easily flip the switch without having to remove the motherboard. So let's go ahead and prepare the headers. Now you'll note that there's 2 rows of 8 pins each that we need to prepare. So you can see here 2, 4, 6, 8. There's my cut point here. I'm going to put it in a plastic bag so it doesn't fly across my room. And you'll notice that Kay was very nice and he gave you some extras, right? But you're going to need to cut those off. So we'll do it again here. And there we go. Now you'll see there's a long side and a short side near my thumb. The short side needs to be closest to the circuit board, and the long side is what you're going to stick into your motherboard. However, it's possible to screw up, and if you put the short side in this way, that's screwing up, right? You don't want to do that. You want to put the short side underneath, right? Now the back of this board looks like this. Both have this SMC logo on them, so don't be confused by that. But look for the angry IC little logo over here. See the little angry guy here? All right. You're going to insert this opposite to him. So means you're going to go here where you don't see the little angry guy, and then you're going to put in the header like so. And then your other header is also going to be in here. And again, these pins are the long side pins. And the short pins, you can see, are sticking up on this side. And this side is where your little angry IC logo is. Now for this little board, it's nice. Kay already pre-cut these for you, so you don't have to do any cutting on the header. But again, there's the naughty way to put it in, right? No, 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 no. You don't want to do it this way. Okay. Now on this board, we'll say the switch side, the IC side, maybe the IC side because you won't have the switch on. The IC side is where you need to mount your switch so that the switch is facing like this, right? And then the short side pins need to go towards the board, but opposite the switch side, so which means it's going to be on this side. So in this case, the little angry guy side is correct, and you want to put it in like this, so that your long pins are sticking out like this. And then on the IC side, we see the short pins are coming through like that. Now I should say one more thing. If and only if you're going to use that extension cable, then you would need to cut your little L-shaped header to 7 pins and then put it in this way. Right? This is the top of the board. The bottom would be double-sided tape, and then the connector is going to slot in to your header like that. Now here's how I recommend soldering the header on this little switchboard. First, put your cut header into a breadboard. If you don't have a breadboard, buy one. They should be cheap enough to warrant, you know, you can use it for a variety of things. Okay? And you're going to put your little board, if I can do it, there we go. But notice he flops around, and you don't want that when you're soldering. You want to be able to solder him flat. So how are you going to do that? Well, you take one of the pre-cut headers you have for the Mac 512 board and slide him under. So the black side is just under there. And now he's pretty stable. So let's go ahead and solder him in. And then I'll do the other side here. Now it's stable. Put a little flex on these others to make them easier to solder down. And here's how our solder joints look after I cleaned off the flux. Great. Okay, now on the 512K board, we need to solder in our header here on this row. Then on this row, we're going to leave this open for now. That's where the other board is going to solder onto. Or if you have an L-shaped, if you want to have the extension cable, you'd put it here. So we're not going to do that yet. And then we have to cut off one pin on, you know, we have a remaining header, right? And we need to cut off one pin, and that's going to solder in here. So I thought about using my breadboard trick again, and you know, that's fine for these pins up here, but unfortunately Kay did not design it with my little breadboard trick in mind. So this isn't positioned for a breadboard use. I mean, this hole, it's not, it won't work if I put it in the breadboard. So I'm going to have to take this out, figure out how to manually solder it in straight later. But what I can do though is I can put it in like so and then solder these in without a problem. So I use my vise for this guy, and I wish I could have used my breadboard on him, but oh well. Put a little flux there, then use my needle nose pliers to fit him in. Getting him straight's the problem though. And solder. He's soldered in, but not really sure how straight he is. Next, I As you can see, I'm not going to use the extension cable. I figured most of you aren't going to use it, so I'm going to stack it like this. And I was able to put both PCBs into my vise so that, you know, you can't use a breadboard when doing this last row of soldering. And then I just flip my vise over and I can solder the last row of pins. Okay, I've cleaned off all the flux, but one thing I noticed on these pins right here, this is our daughter card, our little switch card that's on the opposite side. The height of these pins is higher than the black plastic standoff of these other pins. And since we have to connect these pins to the motherboard, that's not good. So we're going to have to snip off all 7 of these so that they are no taller than the black plastic part of these 2 guys. After snipping, we can see that these little guys are all shorter than the little black plastic part in the background here. Now here is my Macintosh 512K motherboard. This is the second revision board. The first revision was 128K only. And you might notice some things that are a little bit different than your standard board, which is this here. These wires and these 2 chips and this red PCB are the kit from Koba's Raminator. Now, originally created by Big Mess of Wires, but he allowed K to build it because Big Mess of Wires Steve Chamberlain is no longer making them anymore. So please see my video for all the details on the Raminator. And yes, the FatMax switcher, which is this little guy here that I just finished making, he is fully compatible with the Raminator, the floppy EMU, and all of that that's mentioned on Koba's website. The other difference between the stock 512K motherboard and mine is you'll see these capacitors here, these axials. I swapped out, basically recapped, the fluid-filled aluminum electrolytic axial capacitors with tantalums, and these will never have to be replaced. And I have a video on that if you haven't seen it, so be sure to check that out. So again, except for the Raminator and except for these 3 capacitors, what you're seeing here is your standard 512K board. And that is denoted by the 1983-1984 date. The Macintosh 128K first revision board says only 1983 on it. Also, my board will allow it to be built 128K or 512K, and that's why you have these 2 little white boxes down here. So because of that, currently, K probably will change this about the time I release the video. I'm not really sure, but basically when you look at K's website today, as of when I'm making this, it says there's a way to do this for the 128K board and then a different way to do it for the 512K board. However, what he really means is the 128K method for the FatMax switcher applies only to the first revision 1983 board, which means not this one. So in that case, you don't need the bigger PCB from K. You don't need to do the optional 512K kit. You just follow K's instructions on how to do that 128K board. But if you have either the 512K board like I do, or the newer revision 128K board, both of which again are 1983-84 and show these 2 checkbox areas here. If you have that kind of 128K board, then you're going to need to follow the 512K instructions. It's a little confusing, I know, but that's just the way it is. Kay didn't put that on his website at the time I made this video. Now, the differences between the first revision and this revision board usually appear in this section above the 68,000 CPU. The 68,000 is here. You'll see a little difference here, here, and here. And this is basically the area that we're going to install our board here. And so for my 512K board, I'm going to have to remove this IC and these 4 components so that I can just solder him in there, and then my installation is finished. And I don't have to touch the RAM chips at all because this is a 512K board. But if you have a 128K board that is of this newer 1983-1984 revision, you need to do exactly what I'm going to show you, except you'll have to change out all of the RAM chips, all 16 of them, because you need to have 512K in there for this switcher to work. And it'll give you 128K or 512K at the flip of a switch. Since I have 512 already, I don't have to touch these. Also, on the 128K board, you're not going to have this IC and you're not going to have these 4 components. So in that respect, it's a little bit easier than what I'm going to have to do. But it's also harder because you have to swap out your RAM chips. Again, check the text description below because I put a link to where you can buy the RAM chips and the sockets. Yes, you should put sockets in from Jameco. And so check that out. Also on the 128K board, you're not going to have these components here. It says 512K only down here. You're going to have a jumper here at W1. So on your 128K board, you're going to have to remove that. But again, please don't get confused. When I say 128, you could have the older revision board, which, you know, this information here doesn't apply. And you need to follow Kay's guidance on that. Or you could have this board revision with 128K. Okay, so again, it's a little confusing. But if you have a 512K, then it's, well, pretty straightforward. And so what I'm going to do right now is I'm going to desolder this chip and these 4 components. Now, to desolder those parts, I'm going to be using this Goot brand TP-200 desoldering station. And I really dislike this guy tremendously because he sucks. In the worst possible meaning of the word, meaning its sucking power is really bad. And it has been for years. So what I'm going to do is use it in combination with my hot air station set to 350 degrees so I can kind of heat up the place a little bit with hot air in hopes of helping this guy to suck out the remaining solder. And I think that's going to be better than using a desoldering wick. By the way, this Goot brand, this is what I buy for my desoldering braids, and they make really good braids. I mean, it's pretty simple, right? Just a piece of copper, but they make good braids, but boy, I've heard that Hakko desoldering stations are a lot better. I've not tried one, so I don't really know, but I do know that my soldering station is good. So anyway, that's what I'm going to use today. So here is the chip pins. Of course, down here is the keyboard socket, so you can kind of orient yourself. And then the 4 components are right here. And I also need to remove solder from one end of this W1 jumper place for the board to fully solder in. Now this keyboard connector has pieces of plastic here, and I don't want to melt those with my hot air station, so I'm going to put this piece of metal here in hopes of when I shoot the hot air over here, it's not going to melt those little pieces under here. That's my aim anyway. Now they made it nasty. They bent out the pins, so it's not going to be too enjoyable. But probably putting some flux on is a good idea here. Okay, so apply 350 degrees here with my hot air station. And then
Well, that's not working very well, mainly because the pins aren't coming straight out. Try hot air. Bend him, maybe? No. Maybe I got one there, possibly. The bending up of the pins is a bother, because you don't want to lift the pad. Possibly I got those 4. I'm going to try my Hakko soldering station. See if I can move the pins over this way. Have to be careful because these little traces down here, you don't want to scrape the board accidentally. Now maybe if I put some fresh solder in there, maybe it'll help come out. Well, on the component side, we can see we got one guy who pulled right out. Very nice. And this other guy looks like he's wanting to come out. Okay. And the other two, no. Have to shield my, protect my connector here. Okay, so now we just have the chip. All right, back on the solder side, trying to get this chip out. I had a good desoldering station, it probably would have been out by now. Okay. Try our desoldering braid. Well, I got more solder out of him than the desoldering station did. Okay, I got my hook. I'm gonna pull down on him while I apply hot air and see if it does any good. Well, certainly does take a lot of work when you got terrible tools. Boy, I wouldn't want to desolder 16 of these RAM chips. Going through that just for one of these chips, my goodness. Now I still have solder in the holes. So we'll see if my braid can wick it out. Well, solder in some of these, so sometimes adding solder can help. Try it again from the bottom. Maybe put some more flux on it. Well, grab my stainless steel tool kit here. Sometimes you can use these guys. The solder doesn't like to stick to this. And sometimes you can use a hot air station and just poke your way through. And we had the solder come through on this side, so take him out with a wick here. And after cleaning up all the flux with 100% IPA, we can see that all the holes are nice and clean. Now I know at this point you're eager to solder this guy in, but before we do that, it would be prudent to take a multimeter set to continuity mode. Continuity check mode means beeper mode. You touch both probes together and you hear a beep. And that lets us trace PCB traces to where they're supposed to go. And we know where they're supposed to go because I have a schematic. So we really do need to check our connections first to make sure that all of the connections here are sound, and then we can more safely solder everything in. So we know you've got some pins that are going to ground, pin 1, 15, 13, 12, 11, and 10, according to our schematic here, and that's referencing this chip. So over here at the left, at the bottom, is pin number 1, and again, that's ground. So that should be connected to pin 15, which is correct. Should also be connected to pin 13. Yes. Pin 12. Yes. Pin 11. Yes. And I can just touch somewhere else like a metal part. Yeah. And so these are all ground. And of course pin 8 over here. So we've got this pin here. Yeah. Is ground as well. And then we have pin 6, which goes to resistor R40. So pin 1, 2, 3, 4, 5, 6. Yes. And then we have pin 5, which goes to R41. Yes. And then we have pin 16, which goes to C51 up here, and C51 there. Okay, and then on the opposite side of C51, R40, R41, they should all R41, which is here. And so this is the opposite side, and that should be connected to R40. Yes. And both of those will go to 5 volts. Which means pin 16 is also going directly to this point here. And this side, of course, being the ground side here. Okay. And then we also see that pins 6 and 5 are connected to A17 and A18. And because I have Koba's little Raminator on here, I can more easily check those because it tells you up here A17 and A18. So pin 6. Okay, so pin 6, 1, 2, 3, 4, 5, 6 is supposed to go to A17. Yes. And pin 5 is supposed to go to A18. Yes. And then we know that pin 14, 16, 15, 14 goes down to, says the 74AS253 chip, pin 14. So same pin number there. And actually there are multiple of these chips towards the top of the board. Okay, and so here's one of the AS253 chips, and we can see that 16, 15, 14. It is connected. And then we have pin number 2, which is the blue wire here, which goes to pin 2 on the same chip. So again, pin 2, 1, 2, it goes to pin 2. Oh, not that chip, this chip. Yes, okay. And then we know that pin 3 is connected to pin 4, and the green wire goes up, and that green wire comes over to pin 4 on the 26LS32. And the 26LS32 chip is this one here. So we need to look at pin 4 on him. 1, 2, 3, 4. And then 1, 2, 3, 4. Right? 3 and 4, 3 and 4 are connected there. And we see from the schematic that pin number 9 is not connected to anything. And pin 7, so that's this one here, is connected to R42. My label R42 there. And then R42, the opposite end, is connected to the W1 jumper on this side. Okay. Great. Now it's time to fit him in there. Ooh. Ooh. Oh. Wow. Actually, I pressed on him, but you shouldn't press on him because he's kind of hanging by these pins only, the top daughter card here. But press on the bottom. Wow, it fit right in there. And looking at it from the side, we can see that the little black standoff between the red board and the base PCB green board is perfectly flush. It's flat with no gaps there, which is exactly what we want. We also see that the daughter card is pretty straight too up there. And the other little pin over here is a little bit hidden behind this hot glue. We can see from this angle that he's also flush with the PCB. Great. Now I'll just put some flux on him and we'll get going. And here it is after a nice alcohol cleaning, but as you can see, these pins are extremely long compared to the stock pin length, so I will go ahead and snip these off. Now, upon closer examination with my lens, I noticed this teensy tiny little nick. The trace is fine, but the green solder mask was removed it's probably less than 1 millimeter in size. So what I'm going to do is apply just a teensy tiny drop of UV solder mask on it to ensure that that doesn't corrode over time. And after reviewing some of the footage I shot, I see I made 2 mistakes, so I'm going to go back and correct that just to show you. R42 is here, and that should connect to this side of the W1 jumper. And yes, it does. And then we know that this CR5, this side of this component here, is ground. So pin 10 is here. And that's a good ground. So all of the connections fully check out. Okay, it's now the moment of truth, the first test. And I have not tested this off camera, so you're going to see exactly what I see. It always makes you nervous, right? After you've been fiddling with a circuit board. Okay, it's plugged in. It's currently set to the 512K setting. So, 3, 2, 1. Okay, now that sound is normal because I've got the Rominator installed. It's the non-stock sound. And it booted. 512K. All right, and that's what it's supposed to be because I have it set on 512K. And here's the other confirmation it's set on 512K. The blue LED only lights when the switch is set to 512K. I discovered something. Check this out. That's the switch. I didn't need to do the extender after all, it would seem, because I can actually fit my finger just in there and I can push him. Yep, I switched it. Now it's set on 128K. Now the power's off. I shut my computer down, so you don't want to do this with the power on, but you know, if you're pretty careful with it, you can stick your finger in there and do it without the extension cable. Pretty slick. Okay, let's see what happens with the 128K setting. Okay, seems to be the same. Press R. Oh, there it is, folks. 128K, just like magic. But the magic does tend to wear off pretty fast, especially if you're using the 128 kilobyte of RAM setting. Now, before I show you some of that, I should just mention a little bit about my setup here. Instead of a 400K internal drive, which is what the original Macintosh 128K and 512K shipped with, I deliberately installed an 800K drive, model MFD-51W-03. And that's because it just offers me more flexibility, especially because I have the ROMinator inside and it has the 128 kilobyte ROM, which is basically a Mac plus ROM. And it just lets me run a lot more stuff. Plus, I have a floppy EMU connected externally. And these are really nice. If you don't already have one, I can highly recommend them. And this will allow me to use 400K disks, 800K disks, and even boot off a virtual hard disk 20 if I want to, which is really nice. So here I am booted with 128K, so let's go ahead and see what that means in McWrite. And about McWrite, we can see this is version 2.20, memory free 90%, memory used 10%. And we haven't really done much of anything other than load McWrite. We have just a blank document here. So let's see how fast this 128K of RAM starts to fill up when we type a short sentence. Now we can check our RAM again, and we're down to 88%. So we used 2% in just this sentence here. So I'm going to go up here and copy, and I'm going to press Shift Command to paste it in. Make another paragraph, paste it in. So we got a couple paragraphs here, and we're now down to 83%. Okay, so then we select, we don't have select all. No select all back in these days. Copy, paste. So now we have 4 paragraphs of text, and our free memory is down to 73%. So we will select these 4 paragraphs of text, copy, and paste. And so now we have 8 paragraphs of text, and memory free down to 57%. So you can see that after you type maybe about 3 pages, you're going to run out of memory. That's how limiting 128K of RAM is. Now I shut down and switched it to 512K. So let's see how McWrite does with more RAM. Holy cow, 99% free, only 1% used. And go up here and check. No change. That's a full paragraph. Let's see. No change. Okay. Okay, so now it's down to 98. We will select these 2 paragraphs. I don't want to select my ruler. Select the 2 paragraphs only. Copy, paste. 98%. And we have 97% free. We only use 3% of memory for 1, 2, 3, 4, 5, 6, 7, 8 paragraphs, right? So 512K certainly makes a difference. Okay, I've switched it back to 128K. Let's see what we can and can't do with such limited RAM. Full paint, which I really like a lot better than Mac Paint. It's just like Mac Paint, but it gives you more. Sadly, full paint requires at least 384K of memory. So, nope, not on a 128K Mac. Okay. What about games? We've got Megaroid, Stunt Copter, Missile Command. Now, these are the little games that shouldn't take up memory, like for Stunt Copter here. So, even on a 128K Mac, yeah. Yeah, it works just fine. And, okay, well, a bigger game then. Load Runner, probably one of the most popular games ever for these black and white Macs. And, well, it loaded. It didn't complain, right? This is version 1.0. October of 1984. Yowee! Okay. And there's the demo. Well, let's start game. I forgot what the keys are. Okay, we got sound going on here. Oh, oh, there it is. This speaker is loud, let me tell you. So yeah, we've got Load Runner. It's working fine. Hey! All right, and you can just keep going and going and going with 128K RAM. No problem with there. So now if we do memory test, which actually isn't a test, it just tells us that we've got the 128K HFS ROM, free memory 58K. So not a lot of memory at all. And what else? PRAM 2, this lets you set your clock. I really like it a lot. Set your clock. Looks like I need to set it. I guess my PRAM battery must be dead. But it lets you set the year correctly. So you can set it, I think today's the 13th. And it will remember the 4-digit year. Okay, I've now switched to 512K, and I'm booted off of my floppy EMU in hard disk 20 mode, system 3.2, and I've got some desk accessories in the Apple menu, like this hex decimal octal binary conversion calculator. We've got stars 1.3, which shows you flying through outer space. And I've got a massive amount of files in here. You can see almost 20 megabytes in disk, which is, you know, the same capacity as a regular hard disk 20. Huge number of utilities in this folder, which is why I double-clicked it just now and it's taking so long to open, right? A lot of utilities here. And okay, so that's just a basic test of using the Finder, right? And okay, we'll just do one last thing, open up our calendar, showing our calendar here. And now I've switched it to 128K, so let's see what happens here. When I choose my base to base, not enough memory to open that desk accessory. And it's not massive, folks. I mean, it's a pretty small little thing. Stars, not enough memory. Okay. Calendar, let's see if it'll work. Okay, it opened the calendar, which means it's lightweight enough to do. So remember, you have 128K, but you don't have all that memory. It's only like 90K or less that you have actual working memory. So what's going to happen if we try to double-click utilities here? Oh, there's not enough memory to open that folder. So if you have a drive that has too many files in a given folder, the 128K Mac does not have enough memory to open it. Games folder, not enough memory. Rominator flash tool. Okay, so 1, 2, 3, 4, 5, 6, only 6 files in here and he was able to open it. So that's another limitation of the 128K of RAM. And we are still on 128K of RAM. Switcher 5. Sorry, but you don't have enough memory to run the switcher. Go get a 512K Macintosh. Well, we can. Actually, we do. We just need to flip the switch. Okay, also with 128K, Mac Attack. This is perhaps one of my favorite games back in the day. Man, I played this a lot. Such a wonderful little game. And it worked on 128K. But again, we have a 128K with the newer ROM. So let's see. So far, so good. And choose level 1. Oh. Yeah, I know it works with 128K, so this is clearly a ROM error. Boop, boop, boop. What I did is remove the Rominator, and instead I put in the original 64K ROM chip pair in the motherboard. Now technically you can use a software app called Flash Tool to reprogram this. You could put the 128K ROM or 64K ROM in, but I heard some people had some issues with doing that, and I didn't want to accidentally break my Raminator during the course of making this video, so I went with the bulletproof method of removing it and using the actual chips. And when you do that, go ahead and restart the game here. We see that the game is working and no errors. So great. Now keep in mind, in addition to the 64K of ROM, I have the 128 kilobytes of RAM switched on. So let's boot from this floppy disk system 0.85 and Finder 1.0. This is from December 1983. It's actually the same system and Finder that shipped with the original guided tours. And you can probably hear the grinding sound. Also notice that the Welcome to Macintosh box looks a little bit different than it does with 128K ROMs. And that grinding sound is coming out because I have an 800K floppy drive in there and not the 400K drive. It still works, but it's just a bit different sound. And we'll go ahead and load up Mac Paint here. We see this is Mac Paint version 1.0, copyright 1983. Now it's not all a bed of roses with 128K and the stock 64K of ROMs though, mainly because I have this 800K drive. And one of the biggest quirks is, if you have the drive 800K internal, if you connect any kind of external drive, even a floppy EMU, then there's something that's going to happen. Now I had my floppy EMU disconnected, but I'll just quickly reconnect it here and power on. And you can hear bump, 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 bump. It's pulsing. And this is something that cannot be fixed in the hardware. It's not damaging the drive, but it's just trying to access it over and over again. And it's just one of the 64 kilobyte ROM quirks that happens when you have any kind of external drive, even a floppy EMU, attached. And what makes it go away is if you boot with the HD20 in it, which recognizes HFS and 800K disks, and then that pulsing will stop. But of course the main issue with 128K of RAM is you don't have enough RAM to load the HD20 in it. So this is why I removed my 64K ROMs and reinstalled the Raminator. Since having a Macintosh 128KE or 512KE with the 128K of ROM currently in my Raminator supplies me a bit more flexibility, especially with an 800K floppy drive.
So, should you buy FatMac Switcher? Well, if you don't have any desoldering equipment, and if you don't have any desire to buy any, and if you don't have any desire to pay somebody to install it for you, then the answer is pretty obviously no, because it's a kit that has to be installed. But if you have soldering equipment and the desire to use it, and if you have Macintosh 512K or 512KE like I do, then resoundingly yes, buy the FatMac Switcher. But even if you're somebody who is only thinking about buying a 1984 Mac, yes, I would recommend it to you too, because it will allow you to buy the cheaper 512K model, and in combination with the FatMac Switcher, you'll have the coveted 128K Mac. So unless you're a purist who demands that your motherboard be in the absolute stock, untouched condition, or unless you're somebody who is a worshiper of manufacturing dates, there's absolutely no good reason anymore to pay outrageous sums of money for a Macintosh 128K. None. Now, if you already have a 128K Mac, I don't recommend the FatMac Switcher unless you have a better desoldering station than I do, because you saw how much effort and time it took. I actually had to speed up my video. I didn't video it in real time because it really did take a long time, even with a hot air station helping. And you have 16 chips. You know, I only desoldered one, but you're gonna have 16 RAM chips that you're going to have to desolder without breaking any traces, you know. And then you're going to have to buy your sockets separately, install 16 sockets, then plug in all of your RAM chips, then partially assemble the FatMax switcher, then suck out the solder in the holes of where you have to plug in, you know, FatMax switcher. A lot of effort. If you have good equipment though, I think it's doable. And so in that case, and only in that case, I would recommend it for you. Now, don't forget, FatMax switcher gives you bragging rights. You're going to have the coveted 128K Mac, and don't let the purists tell you otherwise. It is. But you also get the benefit of, at the flip of a switch, having 512K. So you can actually have some real fun with your computer too. And that 512K comes in handy when you want to test old software, and then you can flip it back to 128K to see how that software would respond on the quote-unquote first Mac with extremely limited RAM. And that brings our video today to a close. Now, don't go away, because in my next video, I am going to be showcasing some nifty new gadgets like this, which is called the Macometer. It is a very easy to use voltage checker for vintage Macs which have an external floppy disk connector. Pretty neat. I will also be showcasing this little guy, which is a ROM sim programmer that will program ROM sims from popular vendors such as Garrett's Workshop, possibly Koba as well. I still need to test his to determine it. The Rominator 2. Big Mess of Wire Steve Chamberlain used to sell a ROM sim programmer, but there were parts issues that he had to stop making it a number of years back, and KMac Vintage has resurrected it. And so I'm going to be taking a look at that. And that's not all. I also have 30-pin 4 megabyte RAM sims. Now, these are not a kit that you put together. So for those of you who don't like to solder, this is for you. It's turnkey solution. You just buy it and install it. But one of the unique things about this kit, I put a little sticker on it, is that one of the 4 RAM sims is special. It has a special chip on the back and LEDs that acts as a diagnostic sim. It's a usable 4 megabyte RAM sim, but it will also show you visually the reads and writes to RAM so that you can diagnose problems on a troublesome motherboard. And even if you don't have a troublesome motherboard, it just can be a nice light show to show you the reads and writes. So all of that is coming in my next video, so please stay tuned for that. Thank you for watching today, folks. I would be honored, if you like this video anyway, if you'd click the thumbs up button. Please also subscribe and click the bell icon if you'd like to have notifications of whenever I come out with a new video. Also, I look forward to seeing your comments down below. I love interacting with you down there. So I wish you all a wonderful week. Take care, folks.